Okay, so yeah, I'm the strategic manager for Customer Experience Analytics. Customer Experience Analytics team is the team that's responsible for the storage, reporting and analysing of all ticketing data in Transport for London. As this is a transport conference, you probably don't need me to read every single transport mode that TfL runs. So I'll just say that this presentation is going to be about how we're using ticketing data in TfL to benefit our customers and our approaches to open data. So we started using Oyster cards or smart cards in 2003, and more than 65 million have been issued since it was launched. That means there are about 45 million valid cards today, and about 3.5 million Oyster cards are seen each day, which means we have a huge amount of data. Over 8 weeks, we collect about 1 billion taps. We're also expanding into contactless payment cards. You can now use your contactless payment card on buses. There have been over 9 million journeys since it was launched in December in 2012, and we now have an average of over 40,000 journeys a day. And this year it's going to roll out across the rest of the TfL modes that use Oyster. So this is a quick overview of the type of data we have. So we know about the number of entries and exits going through our gates. So every time you tap, we know about that. For the smart cards, if we used to have the contactless payment cards, we can link the entries and exits to make journeys. So we can look at how people are moving around the network like that. We also know what type of card is being used, what type of product is being used, whether it's a pay-as-you-go journey or a travel card journey, and there are different ways that your travel behaviour would depend on that, because when you're using pay-as-you-go, obviously it's an incremental cost every time, whereas travel card isn't. We also know about whether it's people top up or whether they get a refund and other transactional data. So that means we do have a very rich source of statistics. And when we're doing our analytics into journey time, we use pseudo-anonymous data, which means that we can link the journeys together, but we can't then link it back to your registration data of your Oyster card, so we can't link it back to an exact person. So now I'll just give you an overview of what we do with our data. We can do some quite simple business intelligence about how people are using the network, so you can see the AM and the PM peaks. We can also look at trends over time. So on this one you can see the Olympics, when we suddenly transported a lot more people around London. We did that. You can see it's such a large step change, and that's because we actually put on extra services during the Olympics, and there was more, the increases were in the off-peak rather than in the peak period. You can also see this dip here, which was February this year, which was the 2 days of strike that we had. So we did a bit of analysis to understand what was happening during the strike, which I'll just tell you about. So London Underground ran about 35 to 40% of their normal services and had about 75% of the stations open. When we looked at the number of people we saw on LU, demand was about 37 to 43% of what we'd normally expect. But we saw much higher usage on buses and London Overground and DLR. So we saw about 88% of the typical number of Oyster cards that we would see on an average day, which suggests that people were transferring from LU to other modes. Also, because there's such a reduced, they're probably also transferring to walk and cycle or to working from home. But obviously, with the Oyster data, we can't tell what you're doing if you're not tapping. To try and improve the way people were travelling around London during the strike, TfL published real-time information about what services were running on their website and their Twitter feeds. And we found that actually the Wednesday of the strike, so the first strike day, was the busiest ever day on the TfL website, with 2.8 million hits, which is about 3 times more than normal. There was still very high website usage on the Thursday, but not as high as on Wednesday. Also, what we found was that people were accessing this information much more by their mobiles devices while they were on the move. So we saw almost 50% of website access on the Wednesday and Thursday was via mobile devices, whereas on previous weeks it would only have been about a third. Also, we saw a difference in the trend of when people were using it. Normally when you look at the website hits, people start to use it in the afternoon and there's a slow ramp up to an evening peak. But on the strike days, so you could definitely see AM peaks, which kind of makes sense because commuters don't normally need to look up how they're getting there, but obviously without their normal services they did. So we're also using our data to understand what customers want and to provide them with information. Our aim is to improve customer experience, hence where my title comes from, and we're using our data to understand who the people are, how they're travelling, and how they're experiencing our services. So we're looking at things like when disruption happens, how do people react. So the chart on the top right is when there was a problem at London Bridge, and London Bridge was basically closed for an evening, and you can see that loads of people transferred their journeys to start from Cannon Street. We've also got a number of universities looking at our data and trying to understand in a more granular level how people are changing. So looking at people that you can see their normal commute would be through London Bridge and then working out what they did then and why. We're also working with MIT, and they're doing some clustering for us to try and understand the different groups of customers and how they interact with our network. So this very pretty chart on the bottom right shows each column is a day and then each row is a person. And you can, so they're ordered in the first time you saw them in an 8-week period. And the colours represent what time you saw them at. So, so it starts from darkest as earliest and then goes to red as the latest. And then you can start to see different patterns. So you can start to see the weekends through that period. So they're looking to understand if we can group by exclusive commuters, by leisure travellers, and then we can understand how they change when things happen. So we could use this for our travel demand management by understanding which people are that change when we have a campaign, or being able to assess the numbers of people who are likely to change. Could also help us improve our marketing communications because we can target messages much more accurately at people. We're also using our data to improve our network modelling and planning. For those of you who are from London, you'll know that when you get on a bus, you tap on and it costs you the same fare no matter how far you're going, so you don't have to tap off. This means that we only know boarding numbers. So we've developed an origin destination interchange algorithm, again with MIT, which is a tool which infers where you got off the bus based on your next taps. So if you get on a bus and then your next entry is about a quarter of an hour later at a tube stop, we assume that you got off the bus fairly close to that LU station. And this has been used by our planning department to redesign things like Kingston bus station to look at how people are interchanging between buses, and therefore where's the best place to put all the bus stops. And although we had this data before, it was based on manual surveys, and obviously we don't do manual surveys quite as often as we could run something like this. So from the chart on the right, you can see the blue is the boardings, which is what we would have had before, and now we also get alightings and therefore can understand loadings and understand crowding on the bus routes. We can also look at journey time reliability. Before we used to measure reliability based on average statistics, but now we can do a lot more. So this is just a quick run through a case study from Heathrow to Hammersmith. So we started by analysing historic journeys between two destinations where there's only one sensible route between the two. Then we added in what really happened for our customers, and then looked at the cause, and this has been fed back to our operations team and continues to be fed back so they can understand the implications of what they do and can start to use it for when disruptions happen on the network, what should they do to improve the service for the customers. So that's what we're doing at the moment, but we've got lots of ideas of other things we could do. Maybe we could use Wi-Fi data at the moment for Oyster data, or for our ticketing data, we understand where people get into the network and out, but we don't know your routing between it. So if there's a place where there's 2 different routes, then we can't work that out. But maybe with the Wi-Fi that we're putting on all the stations, we'll be able to understand a bit more about that. We could also link our ticketing and bus information to traffic congestion information to understand more about how the bus and the rail network works together, and whether we can use that to assess where we should put in more bus priority or less bus priority. Also interesting, we are also thinking about social media. Oyster data is very good at the what people are doing, but not why they're doing it. Could we use social media to understand a bit more about that? For example, during a disruption, could we understand how people make their decisions? If there's weekend engineering work, we find it very difficult to understand how much demand we suppress because of that. If the Jubilee line's down, do you decide to go shopping in Westfield instead of Oxford Street, or you decide to go by car out to Bluewater? That's the type of stuff we don't know, and we wonder if you can get it from social media. We've done some initial proof of concepts, but haven't yet managed to prove that it is possible, but it's still something we'd like to look into in more detail. We're also trying to publish more of our data. So we've got a transparency page on the TfL website where we regularly publish information about how many contactless journeys are going on, how many refunds we give and things like that. We've also got a developers area where we publish a lot of information, which I'll talk about in more detail when we talk about open data. And then we're also encouraging the use of our data across TfL, and that's a big part of my role, to go across TfL, understand the business questions they've got, and to work out if and how our data can help. So now I'll talk a little bit about our approach to open data. We feel that as a public body, our data is public, and therefore it should be out and be able to be used. No. We feel that the open data allows information to get to a wider audience and for the reach of our information to be much larger. It promotes the optimal use of the transport network. The more information is out there, the better information customers have to be able to use the network to their advantage. There's also an economic benefit and the benefit of innovation if more people can see our data. So we try and put the service locations, restrictions, timetables and real-time operation out as open data. And we work with application developers to ensure that outputs deliver against our business objectives, and then also to try and stimulate improvements where the market wouldn't necessarily do that. So, for example, accessibility and safer travel. So the outcomes of our open data policy: there's over 5,000 developers registered, and they're using around 30 feeds and APIs that are available on our website. There's significant reach of our data, therefore, because the developers have created over 100 apps, and I'm sure some of you probably got them on your phones. And we believe that the benefits are about 58 million per annum in terms of customer time saved, which related to a cost of under 1 million for us to produce the open data. However, the Oyster Journey data isn't open data because it is sensitive. But with our aim to improve innovation and analysis of this data, we do work with universities so that they can work with us on real-world problems and help us provide support on operations, planning and strategy. So for example, the ODX tool, or the Origin Destination Inference tool I talked about earlier, started as a number of projects with MIT, and we're now industrialising it and bringing it into our systems. So we do a combination of directly commissioned bespoke research for us, and also data partnerships, where we release encrypted Oyster data to organisations under controlled conditions for analysis. So that's it. So I've just given you a very quick overview of how we're using our ticketing data to understand customers, to improve our network modelling and planning, and our operations, and our approach to open data.
So that was an on-time presentation from TfL. I didn't have a chance to put up my my 5-minute warning, which means that we can take the opportunity for any quick questions, please, or points of clarification. Yes.
Thank you. Tom Cohen, UCL Transport Institute, and I'll try to be quick. You talked about pseudonymous, I think was the word you used.
Pseudonymous, yes. I think it might be a made-up word.
Okay, I'm all for that neologism. I was wondering whether there was an opportunity to work the data together with people's own recollections. So we always struggle with travel diaries because they're such an accurate way of understanding how people have travelled, but Oyster gives us a pretty accurate story. Would it be possible, and maybe you already do this, to sit down with people and say, this is your record of journeys, now let's talk about the trips you made and the decisions you made, and why you didn't do this or that?
We've done a little bit. We're a bit unsure about quite how people will take it. But we have, for example, the London Travel Demand Survey does ask for your Oyster number, and then we could in future link the two together, then anonymise it and do research. It's something we're trying to understand. It depends on the types of questions. We're worried that people will be slightly freaked out if you turn up to them and go, so we saw you at Balham at 8:05 on Tuesday morning, why were you there? But yeah, if you ask the question in the right way and we let the customers know how we're using their data, yes we could, but we couldn't use it for all the data we've got sitting there. We'd have to do it bespoke.
Paul Gray-Raven, Sheffield University Open Institute. You mentioned there that you don't share Oyster journey data with the sensitive, but you do share it with the Met. Is there anyone else that gets shared with?
No, I don't think so. And yeah, that's obviously for crime reasons. We don't share it because theoretically you could track people if you know exactly who it is and things like that. So that's why we use the pseudonymous, which basically means we encrypt the Oyster card number so that you can see the journeys that an Oyster card is making, but you can't see who's making them.
I've got the same claim to anonymity that GCHQ and NSA have been making recently.
Okay, that's a good moment to pause, because there might just be a theme emerging there that we want to pick up at the joint Q&A session. So thank you very much.
Okay, thank you.
Maeve.